Inquiry. Change by chipping? This artist is changing a piece of wood into an instrument that will make beautiful music. He planned and chipped, measured and shaped. Chips of wood flew and rough edges became smooth. Although the wood changed shape, it remained wood. Its identity did not change, just its form. Physical changes. How would you describe water? If you think about water in a stream, you might say that it is a cool liquid. If you think about water as ice, you might describe it as a cold solid. How would you describe the change from ice to water? As ice melts, some of its properties change, such as the state of matter, the shape, and the temperature, but it is still water. In Lesson 2, you read that substances and mixtures can be solids, liquids, or gases. In addition, substances and mixtures can change from one state to another. A physical change is a change in size, shape, form, or state of matter in which the matter's identity stays the same. During a physical change, the matter does not become something different, even though physical properties change. Change in shape and size. Think about changes in the shapes and the sizes of substances and mixtures you experience each day. When you chew food, you are breaking it into smaller pieces. This change in size helps make food easier to digest. When you pour juice from a bottle into a glass, you are changing the shape of the juice. If you fold clothes to fit them into a drawer, you are changing their shapes. Changes in shape and size are physical changes. The identity of the matter has not changed. Change in state of matter. Why does ice melt in your hand? Or why does water turn to ice in the freezer? Matter, such as water, can change state. Recall from Lesson 2 how the particles in a solid, a liquid, and a gas behave. To change the state of matter, the movement of the particles has to change. In order to change the movement of particles, thermal energy must be either added or removed. Adding thermal energy. When thermal energy is added to a solid, the particles in the solid move faster and faster, and the temperature increases. As the particles move faster, they are more likely to overcome the attractive forces that hold them tightly together. When the particles are moving too fast for attractive forces to hold them tightly together, the solid reaches its melting point. The melting point is the temperature at which a solid changes to a liquid. After all the solid has melted, adding more thermal energy causes the particles to move even faster. The temperature of the liquid increases. When the particles are moving so fast that attractive forces cannot hold them close together, the liquid is at its boiling point. The boiling point is the temperature at which a liquid changes into a gas and the particles spread out. Figure 11 shows how temperature and change of state relate to each other when thermal energy is added to a material. Some solids change directly to a gas without first becoming a liquid. This process is called sublimation. An example of sublimation is shown in Figure 12. You saw another example of sublimation in Figure 5 in Lesson 1. Removing thermal energy. When thermal energy is removed from a gas, such as water vapor, particles in the gas move more slowly and the temperature decreases. Condensation occurs when the particles are moving slowly enough for attractive forces to pull the particles close together. Recall that condensation is the process that occurs when a gas becomes a liquid. After the gas has completely changed to a liquid, removing more thermal energy from the liquid causes particles to move even more slowly. As the motion between the particles slows, the temperature decreases. Freezing occurs when the particles are moving so slowly that attractive forces between the particles hold them tightly together. Now the particles only can vibrate in place. Recall that freezing is the process that occurs when a liquid becomes a solid. Freezing and melting are reverse processes, and they occur at the same temperature. The same is true of boiling and condensation. Another change of state is deposition. Deposition is the change from a gas directly to a solid, as shown in Figure 13. It is the process that is the opposite of sublimation. Key concept check. How can removing thermal energy affect the state of matter? Dissolving. Have you ever owned a saltwater aquarium, such as the one shown in Figure 14? If you have, you probably had to add certain salts to the water before you added the fish. Can you see the salt in the water? As you added the salt to the water, it gradually disappeared. It was still there, but it dissolved or mixed evenly in the water. Because the identities of the substances, water and salt, are not changed, dissolving is a physical change. Like many physical changes, dissolving is usually easy to reverse. If you boil the salt water, the liquid water will change to water vapor, leaving the salt behind. You once again can see the salt because the particles that make up the substances do not change identity during a physical change. Key concept check. What happens when something dissolves? Conservation of mass. During a physical change, the physical properties of matter change. The particles in matter that are present before a physical change are the same as those present after the physical change. Because the particles are the same both before and after a physical change, the total mass before and after the change is also the same, as shown in Figure 15. This is known as the conservation of mass. You will read in Lesson 4 that mass also is conserved during another type of change, a chemical change. Key concept check. What is meant by conservation of mass?